Okay, we've taken care of our ratio test. Now let's go ahead and take a look at our root test. All right, so for the root test, we are going to let my series a sub k be an infinite series. And they use rho. Now, rho is a Greek letter that looks like this. What does that also look like? A P. And I'm dealing with this P series. We're basically doing the exact same criteria that we did for the ratio test, but I don't really want to put this something that looks like a P in here for this rho, because then you're back to the P series, and I think that's very confusing. So if you're looking at your book, it uses the Greek symbol rho, R-H-O, even the lowercase of it. We're not doing that. I'm going to go back to R again, because it's just a variable that otherwise it has no significance. So we're going to let R equal the limit as k approaches infinity. They have it like this. The kth root. I'm not going to write it like that. What is the same thing? What's another way to write a root? Yes, fractional exponent. So my limit as k approaches infinity here of a sub k to the 1 over k power. This is how we are going to write it, because as you will see, it makes more sense. All right, then the same criteria apply. If R is less than 1, the series converges absolutely. Two, if R is greater than 1, the series diverges. If, I'm going to scoot this in a little bit, R equals 1, the test is inconclusive. So the criteria for the ratio test and the root test are exactly the same. The method, the ratio test, you set up a fraction, right? You divide that fraction, still the absolute value. For the root test, you're taking the root. So in order to take the root of something, your tip off for this is you're going to be looking for exponents. That's how you know. Whenever I have the root test, I am going to be looking for exponents. How much room do we have here? Oh, I believe we have enough. Let's give this a whirl. Here is example 2. A. Here is my series. I'm going 3 minus 4k squared over 7k squared plus 6. All of that is to the k power. There is my exponent. That's the exponent I'm talking about. Now, if you have your base as a k to a k, that's your ratio test, because that base is a k. If it's just the k as the exponent, that's where you're looking for your root test. So let's do it right now. I'm going to take the limit as k approaches infinity of 3 minus 4k squared over 7k squared plus 6 to the k. All of this is to the 1 over k power. Now, when you have a power to a power, you multiply. K times 1 over k cancels out. And that's the beauty of this test. So I now have the limit as k approaches infinity of 3 minus 4k squared over 7k squared plus 6. So I'm just taking the limit of this rational expression. I have my leading coefficients when I take this limit. So my answer is really not negative 4/7 because it's that absolute value here. So it's just 4/7. Which is less than 1. What was my criteria for less than 1? Converges absolutely. Therefore, the series converges absolutely by that root test. Good. All right, not too shabby, right? Cool, let's do one more. So, if I have example 2b, my series goes from 1 to infinity of negative 2 to the k over k to the 10. Pardon me. Then, here's my other tip-off. So, this is to the k power. This, I don't care, well, that's fine, whatever. But this is to that k power, so that is my defining characteristic that I'm going to be using that root test. All right? Ah, doggone it, I did it again. I didn't write out my r. So r is equal to this, r is equal to this. So r is actually equal to this 4/7, which is less than 1. Okay, you get it. So r is equal to the limit as k approaches infinity of negative 2 to the k over k to the 10th. All of that is to the 1 over k power. Now, whenever I'm taking this fraction to the 1 over k power, you have to take this 1 over k to both the numerator and the denominator. So, power to a power, you multiply. You get negative 2 in the numerator, because the k over k cancel, over k to the 10 over k power. Right? So, now, if we're looking at this, I have negative 2 here, so the absolute value of that just ends up giving me a 2, and I get 2, so r is equal to 2 over, now look what's happening here. If I have infinity, what's happening to this? This is giving me now infinity to that 0 power. When you are just, so it's, the whole thing doesn't go infinity to the 0, right? That was our indeterminate form. The whole thing is not doing that. But if I'm having this, anything to this 0 power, because it's only in the denominator, do you see what's happening there? Because this is only to the denominator, as k goes to infinity, my whole denominator here is going to this 0 power. So this is like to the 0 power. So anything to the 0 power is going to give me what? 1. So if I take the limit as k approaches infinity of k to the 1 over k, just exactly like that, every single time, then we will get that 1. So I end up with 2. If r is equal to 2, 2 is certainly greater than 1, so we know that this diverges. Therefore, the series diverges by the root test. Defining characteristics. To that variable k, as long as k is not your base, we cool, right? But if it's k to that k is an exponent also, then you have to use your ratio test, or if you have factorials. If you just have exponents, like in these problems, the root test would work great.